So let's talk about the Chapter 3 lecture on the Intro to C Sharp. So today's lecture we're going to be talking about all the very basic syntax of C Sharp and how you would write a console application and how you'd write a Windows Forms application. So what you'll notice throughout all of these lectures is that I generally go over a lot of code examples from the book. Now I've posted these online in Canvas, and so you can download all of those and extract them, and you'll see a folder something like this. They'll have book code examples in all the various chapters. So for instance, we're going to be going over some chapter 3 examples today. So the first one we're looking at here is in this figure 3-1. So as I'm going through these book examples, this is where you would get those examples of code if you'd like to look at them later on. We're also going to be looking at some programs that I've written for you ahead of time. And so online, included in all of those files will be this. In Canvas, you can also download all of the example programs that I've written for you. And don't forget, in our syllabus, I've got a list for which assignment those particular example programs will help you with. So let's go ahead and get started now. And this first one, we're going to just deal with a console application. Now, what I generally find with my students is they are so sick and tired of writing basic console applications in C and C++ or Java. And in this class, we're going to start off looking at some console applications just because it's easy to look at the code syntax using console applications, but for the entire rest of the class we're just going to be using Windows-based programs. So they'll all be GUI based. And you only have one assignment on assignment number 1 that has a console application, and all the rest are all Windows based. So just think of it that way. You have one little simple console program and that's it. So let's go ahead and take a look at this program from the book. And let's just kind of walk through some of the basic features of C# and the syntax itself. So the first thing, commenting. We have to have lots of commenting in our code. So in C# to write a comment, you just use 2 forward slashes. So we can come down here, we can see, let's say we want to write a comment. We've got some code, we just do 2 forward slashes, and then we can write our comment however we want. Now the thing is for our assignments and all of our code, we always want to make sure that, for instance, our class, we always have a comment. So this you do 3 forward slashes and it automatically puts in this thing called an XML comment. And then so you can say, this is my program class. And so this just wrote a XML comment associated with this class itself. And so what's really nice about this is this helps with your IntelliSense that other people are using your class. This will pop up for the help for the class. Also, you can create UML diagrams from these XML comments, and there's other programs that can extract things out and create design, reverse engineer designs for you, and they use these XML comments. So you always want to use XML comments. Another place, well, let's say we just have this variable int I. Again, you do 3 forward slashes, 1, 2, 3, and it creates this. Then you can say, this is my comment or whatever. And so now you've just created an XML comment for this class level variable. Now within methods, you would just use the 2 forward slashes to write a comment. So that's commenting in C#. If you want a multi-line comment, what you can do is do the / asterisk, and then you can see how it goes all the way down, and then you can actually just do another / to actually end that comment. So now this is a multi-line comment. So the next thing, let's just start back at the top and work our way down. So in C#, you'll notice we've got these things called using statements. So this is a test question, for instance, where I'm going to say, if you're including a namespace, what is the keyword? And it's using. Every language sort of has different, so Java you're going to see a keyword, C++ you're going to see keywords, so you'll see things like imports in other languages. In C#, it's the using statement. And so these are what are called namespaces. You can see, even if I highlight them with the IntelliSense, you can see namespace, system, then you've got all these various namespaces here. You can actually have namespaces within namespaces. And so what namespaces are is they're just a way of grouping various C# features into related categories. So it's just like a Windows file system, for instance. You've got, your desktop folder. Then within that, you can create, a folder called My Files. And then within that, you can create another folder, called My Music, something to that nature. And so that's actually what they've done here, is they've just created just a way of categorizing the way of holding the code. So you can see you've got a system namespace, a collections namespace, and then a generic namespace. And so this is just a way to organize code. And this is how, if you have classes like this program of the same name, there's no conflicts as long as they're contained within different namespaces, just like in your Windows folders. Let's say you have, a text file called My Text File. You can't have two text files called My Text File on your desktop, for instance. They can't be called the exact same thing. However, if you create two different folders on your desktop, you have folder 1 and folder 2, you can have the same file name, My Text, whatever text program, in both of those folders. So it's exactly the same with namespaces. So what do namespaces actually do? Well, they're just simply a shortcut for your code. And so what I mean by that is this is just a way that you don't have to reference the entire path to the code you want to use. So for instance, there is classes that are defined within here, something called the console class. So if I type console, you can see it knows about the console class. And you can then read the IntelliSense right here, and you can see class system.console. So that means the console class, this code Microsoft's already written for you in the .NET framework, they've contained that within the system namespace. So if you ever wanted to write your own console class, you could. You would just have to put it in your own namespace or your own folder. That way it separates it. So the reason I can just say console and it knows about the console class is because of this using system namespace up here. So you can see how it's in the system namespace. So what we could do, if I were actually to go up here and let's comment out using system. So now I type console and you can see there's no IntelliSense that pops up. It doesn't know the console class is because I haven't given it that shortcut to where the console is located. However, I could say system, there's the namespace, and we can see these little brackets. That means, hey, I'm looking at a namespace. We can see system namespace. Now if I say dot console, so now I have to fully qualify where that console class is located. Okay, let's say what's really nice about Visual Studio is, let's say I forgot to include the using namespace at the top, but I still typed console. So what's actually nice about it is when you click it here on the console class, you get this little light bulb. If I highlight this down, it actually gives me some different options. And you can see it actually went out and said, hey, did you really mean to include this using statement at the top? So if I click this, you can see it actually gives you a little sample code, and it's going to actually write this for us up here at the top. Or did you really mean you wanted to fully qualify system.console? Or hey, did you actually want me to go ahead and just create a class called console for you? But hey, what we really meant was a system or using system. So I click that, and you notice it goes ahead and puts that up there at the top, and now it knows about console, and so now I can use the methods within the console class. So this console class, where is this code actually located? And why can I use it? Well, by default, when you create a console application, there's these references that are automatically included. And sure enough, here's one called system. And so if we were to come up here and do view and go to properties window, you'll see what it's actually done for this system class. So we come over here, as you can see that they've actually included this file called system.dll that was part of the 4.5 framework, .NET framework. So what they've done is Microsoft's written all of this code for you, and part of that code that they wrote was something called the console class. They put all that code into the system.dll. Within this DLL, there's lots of different namespaces. Inside those namespaces, there's lots of different classes organized into those various namespaces. So in this DLL, there's something called the system namespace. And so that's how we can actually use that code. So when we include this DLL within our project, we now can use any of the code inside that DLL that Microsoft has already written for us, just like this console class that we want to use. So that's what the using statements up here are doing. And by default, when you create a console application or a Windows application, they're going to go ahead and just create some here for you. So now we scroll down here, we've got this namespace. So this is the code we're writing now, and we can call this namespace anything you want, and it usually defaults to the name of your project here. And so you can name this banana, whatever you wanted. This is your namespace now. So then we scroll down here, and everything within C# has to be contained within a class. So you can see in this particular example, they're calling it program. So we're saying we're creating a class called program. Again, you could have named this whatever you want. Later on we'll create our own classes, but this is the default class when you just create a brand new console application. So when we scroll down here, here's our main method. Now main starts all C# programs, whether it's Windows Forms, whether it's WPF, or whether it's console. And that's a test question. There has to be a main method that starts your application. So then we scroll down. Now the thing about C# is it's a very rigid, structured language. And so what I mean by that is it's going to be very similar to C++ and Java, where you've got these brackets and you're going to have semicolons, and it's case sensitive, so it's not very forgiving. Where something like Visual Basic.NET is a lot more forgiving language, especially things with like casting. In C#, casting, you have to very explicitly cast everything, where Visual Basic will try to figure out what you're trying to do. So now let's go ahead and write a little bit of code. And so what we're going to do first, is we're just going to go ahead and run this little console program first. And so I'm going to go ahead and just run this is the very first example from the book, figure 3.1. And you can see all it's going to do is output this message to the console. So I run this program, and you'll notice it's actually going to pop up, and then it's going to close down really quickly. Obviously that's not what we want. I'm not sure why they did this with the console programs in the book, but it's actually doing exactly what they programmed it to do. And that is to start here on main, write this out to the console, and then it ends the program. So with this particular example, what we want to do is we're going to say console.read. And what this line of code is going to do for us is it's just going to pause at the console until we press a key, and then it's going to stop it. So let's go ahead and run that again, and we can see welcome to C# programming. I press enter and it closes down our application. So let's take a look at this particular example 3.1 from the book. So our main method executes when we run it. It prints out console.writeLine, and then we just read a line from the console. So when we're accessing the console, we can use this console class that was part of the system namespace. And within the console class now, we can use our IntelliSense to tell us what methods are available. So I can say console dot. So I'm saying, hey, I want to use this console class, and now I want to use some methods within this console class. And the two that you're mainly going to use are write and writeLine. However, we can scroll through here, and you can then look through all the properties and methods by using the IntelliSense, and then you can highlight them, and you can see the XML comments will pop up here so you can read about what the different ones do. So you'll use writeLine and readLine to output data and then read data back in. So but if I start typing write, you can see it actually writes some out, but now if I do writeLine, it actually does a line termination at the end that it's printing out. So depending on whether you want a new line character printed on the end or not is whether you do writeLine, or if you want it kept on the same line, you would just do console.write. And so in this particular instance, they've done writeLine. So it's going to print this text out, and then it's going to print a new line character. So with C#, again, make sure everything is case sensitive. So if I say console, it's not going to know what I'm talking about. You can see it actually gives me these squigglies. It doesn't know what the heck you're talking about. You actually have to make sure you say console. Now what's nice about the IntelliSense is even if I do type console, then I press tab, it's going to go ahead and just fill in the console class for me, and it's going to upcase it. And that's exactly the same with the methods. If I say write here, it's not going to know what this method is. This has to be capitalized on the W. So be very careful with that. But the IntelliSense tends to help you get through that. So in C#, if we want to print out to string, we have to make sure that we enclose it in quotation marks. So you see console.writeLine, and we want to write out this particular line of text. Now when we say console.writeLine, when I actually open up this method that I'm calling, you can see the IntelliSense pops up, and it's going to tell me the parameters I can pass into this method. And you can see there's actually 19 different ways that we can call this WriteLine method, and I can then go ahead and scroll through these. And you can see I can pass in a Boolean value, I can pass in a char value, decimals and doubles and all these things. And the one that we're going to actually use is the string, and it'll actually figure out what you're passing in for you. So I'm passing in a string, and then it tells you what that parameter is that it's expecting right here in this value, the value to write. So that's how you can figure out what you're supposed to pass into these methods. Another thing you can do is I can just highlight these, and you can see the IntelliSense pops up for me and tells me what this particular method does. So this is a very basic console program. We've got our using statement that way we can just kind of shorthand. We don't have to say system.console every time we do this. Our main method starts our application, and now we're using the console class to use this method to print something out to our console. And then we can read some data in with console.read. So this read, you'll actually be able to then read in characters from the console. So that's how you would actually read input back in. So if let's say you're trying to tell the user to input a number or input their name, you'd use the console.read. So within the console.writeLine, one of the things you can actually do is use something called escape characters. And so what that does is that's a way of sort of formatting other types of special characters in here. So for instance, \T, if I run that now, you notice it actually printed a tab inside my string. So \T says, hey, print a tab. If I did \N, and now I press F5 to run, which is also the same, if I come up here to my build menu, you can see I can build the solution, which just compiles it, or I can actually debug, and you can see F5 says start debugging. So I just press F5, and it runs my application. You can see it actually printed a new line character. And so things like text boxes or the console.write, this is one way you can format your code. So you can do \N for a new line character, \T for a tab. If you actually want to print, say a backslash, you just say \\, and then you can see it actually printed the \/ right there. So that's how you would do that. So now let's talk about message boxes. So this is in Windows Forms now, where we'd actually write message boxes. So what message box do is that they just are a way to either give the user a simple message, or they're a way of getting a value such as the user click the OK button or cancel button kind of a thing. So what we're going to do is we're going to write ourselves a little Windows-based program here, and this again is already a program that's been completed in Canvas, and you can download the full code, and it's called Chapter 3 Example Program. Sorry, Chapter 3 Example Message Box is the name of this program. And so here's the application that we can bring up. And what we can do is when we run this application, we can take a look at it. You can see we can type some text into this, click this button, and what that's going to do okay, so we're going to write the code to finish that, so when it clicks the button, it's going to go ahead and pop up our own message box. So what we want to do now is we want to go ahead and create a message box that's going to pop it up with a message that the user has inputted into this text box here. So you'll notice this is going to be extremely similar to your first assignment. So you can almost copy and paste a lot of the code we're about to write here into your very first assignment, where you actually have the user input a message, you have to add a label on there, you click a button, you pop up the message box with their text, and then you have to say which button was clicked by the user. So let's go ahead and do something virtually identical to your first assignment. So with a message box, it actually returns a result in something called the dialog result. So I'm going to go ahead and create this variable now, and then I'll show you how you would know this in just 1 second. So I'm going to say dialog result, my result. And so what this is going to do is this is going to create a variable called my result of type dialog result that holds the return value. Like, it just basically says, hey, did the user click OK or did they click cancel? This is the same way as you would create a variable like an integer I, something to that nature. All we're doing is creating something called a dialog result, which happens to be a enumeration, but we'll talk about what an enumeration is in a later lecture. So now we've got a way of returning the value back to us. So I'm going to copy this my result, paste it here, and I'm going to set that equal to my message box. So here's my class. So if you want to pop up a message box, you just say message box. And you notice I can highlight this and I can get my IntelliSense now. It says displays a message box that can contain text, buttons, symbols, etc., etc. Well, let's just go ahead and use it. Well, message box is extremely easy to use. And so we can just say dot show, for instance. And that would show some text on our message box. Now what I've done in a lot of these example programs is I've just written a bunch of comments here throughout the program so that when you go back and read this code, you'll kind of know exactly what it's doing. Now within C#, again, it's very rigid language. So we've got our brackets that open and close our methods, if we have if statements, and we always have to end all of our statements with a semicolon. That's how it knows. Now one of the things is if I leave that off, when I try to compile it, it's going to give me various error messages. So if I try to run this, you'll notice it's going to say, hey, we've got these build errors. You know, do you want to run the last successful build? Well, no. I actually want to see what the errors were, so I click no, and it actually pops up with this error list window here, which I believe you can get through the view, and then there's an error list window right here if you need to bring it up yourself. But you can see it's actually smart enough to say, hey, you needed a semicolon on this particular line. So I could double click it and it would take me right to that line. So let's scroll back to the top here. I double click this and you can see it actually takes me right to that line of code, and it just said, hey, I expected a semicolon here. If I fill in that semicolon on the fly, it's kind of like compiling it for you. It's nice. You don't actually have to even compile the program, and it figures out where a lot of your errors are. And now it's saying, hey, you have to actually pass something into this show method. You can't just pass in 0 arguments because we haven't written this particular code. So I'm going to go ahead and close this down now. And so let's go ahead now and pass in some parameters to the show method. So let's back up here and let's actually open up our parenthesis, and you can see there's all kinds of different ways to call this message box show. There's actually 21 different ways. And so what we want to do is let the user type in some text to our text box here called text box 1. When they click this button, you can see that calls this method. We want to pop open a message box that displays whatever they've typed into the text box. So let's actually concatenate a string onto that first. So let's say you typed, and now see we added a little space onto that. Now to concatenate text in C#, you use the plus sign. In something like Visual Basic.NET, you use the ampersand. And again, every different language is going to have different ways to concatenate strings with their own little various syntax. In C#, you use the plus sign. So what do we want to concatenate here? Well, whatever the user typed into our text box. So I've got this text box called text box 1, and I want to pull out of it the text property. So if you remember before, we wrote to this property, so we said textbox1.text equals something, but now we're going to access this property and get the data out of this text box. Okay, so this is the message now that we're going to pop up. Now if I actually type an open or the closing bracket, so if I just finish off this parenthesis, I'm just going to press Shift 0, which prints that right parenthesis. Now watch what happens. So it'll actually skip over that parenthesis most of the time. it'll normally work, but it'll won't actually print it for you. And then let's complete that. So now let's go ahead and run it. Let's just type something like ABC, click our button, and you can see you typed ABC. And so it just executed this code right here. Click OK, and the OK button is actually now going to be stored in my result, but we're not going to do anything with that right now. So let's go ahead and close that down. Now if you had just wanted to compile this code, but you didn't want to execute it, you could click Build, and then Build Solution. And that goes now build your code, and then if you had any errors it would pop up and you could fix them. So that's just another way to actually build your solution down to that exe. So now that we've done this, we want to actually do a little bit more. So let's do comma and then space, and you'll say, okay, now there's more ways that we can pass in and call this method. So the next one you can see is, hey, pass in a caption. So okay, so let's say this is a caption. Now let's run it. So now we run our code, type some text in here, click this, and you can say, see, this is a caption. Click OK, close this down. So let's scroll over to the right a little bit. So now what else can we pass into this particular method? So I just put a comma here, and we say, okay, so what other ways can we call this last one? Oh, there's something called message box buttons. So what this is, a message box buttons, is just saying a way of telling the message box what things you want displayed on it. So for instance, do you want to display the OK and cancel buttons? Do you just want to display OK? Do you want yes, no buttons? So how do you do this? Well, you can actually see. So here we passed in a string, which was the text here. For the caption, it expected a string to be passed in. Well, now it expects us to pass in something called message box buttons. So what I'm showing you here is how you actually read the IntelliSense to know what to pass into this method. And in this case, we had to pass in something called message box buttons. But what's nice about Visual Studio is you'll notice that it actually goes ahead and actually finds the IntelliSense something called message box buttons for you. So it just popped up right to that. So all I have to do is press Tab, and it says, okay, now I've got this message box buttons, which just happens to be an enumeration, which is just a list of things that you can select from. And if I press dot, now it gives me the list of buttons that I can display on my message box. So I can do an OK, OK cancel, yes no, or yes no cancel. Let's select OK cancel. So I go ahead and press tab. It populates that in. Let's run it again. This pops up. I do ABC, click my button, and you can see I have OK and cancel. Now these are the things that are going to get returned back into that dialog result variable. So I can pop up like, hey, did you really mean to delete this file? OK or cancel. You click OK, you delete the file. Click cancel, then you do not delete the file. So that's what you'd use a message box for. So another way that we can call this, let's scroll over, we can actually pass in something called a message box icon. So you can see now, hey, it's also expecting a message box icon. So what's that? I press tab, press dot, and you can see these are just various things that we can display on our message box to sort of give more information. So maybe we double click here, so we're going to select error. I run it now. You can see ABC, click the button, and you can see I actually get this little error here, and I get OK cancel buttons, and here's my caption. So now the next thing we're going to want to do is figure out which button the user actually clicked, so we could take some action because of the button they clicked. So we come back down to our code. Now down here, I've actually got a label on the form that we're going to return our result to. It's called label1.text. So I'm saying within my label, I want to set the text property of my label1. And so we're going to say you clicked the, then we're going to concatenate on whatever the user button they've clicked. So for instance, I'm going to just copy and paste my result dot toString. So what this does is it says, okay, tell me, and just print it out as a string, what the result was, whether it was OK or cancel. So this is just going to get the string of what they clicked. So this is just the toString method within this my result. So I can say concatenate on button. Now watch, if I finish off, I'm going to type a double quote again. You can see how it just skips over it and it doesn't actually print it. That's the way that you can, without having to switch to your mouse to click after it, you can just click a double quote and it just kind of skips over it. So this is going to pop up a message box, read in, figure out which button they clicked, and then I'm going to display that result. to them. So let's run it, type in a message, click here. Now if I click OK, you can see you clicked the OK button. There you clicked the cancel button. So that's the very basic message box and how you use it. Now message boxes are nice for something like asking a question like, did you really mean to delete this file? Or confirm you want to submit your data or submit your payment, something of that nature. Message boxes are bad for things like error messages. So it just gets really annoying to a user when you're popping up message boxes for error messages. You generally want to do just labels next to whatever input. So like you click a submit button and they forgot to enter first name, where you'd just highlight the first name text box. Don't pop up a message box telling them they forgot to enter that data. It's just kind of an annoying way to actually do that. So I'm going to go ahead and close down this application, and I'm going to bring up now another console application that we're going to walk through, and this one's an addition console application. This is figure 3.18 for the book example. So we've got this class called addition. Here's the main program that starts our program. Now, so here's a new concept. So they've created 3 variables for us. Now again, you're going to notice that it looks just like C++ or Java. So the syntax itself should be very familiar. That you just say, hey, what type of variable do I want to create? And oh, here's the name of my variable. So within C#, I can start typing something like a double or decimal if I want to hold something with a decimal value. And the difference between a double and decimal just depends on how much data you need to store to what accuracy kind of a thing. So if you want to do something like that was dealing with money, you would use a decimal data type. So we've got int, we have things like chars if you want a single character, we've got ints, doubles, we've also got strings that we've already been working with, and these are all the primitive data types contained within C# or inside the .NET framework. So they've just created 3 variables that can hold integers, and they've called them number1, number2, and sum. Now let's say you were just coming into someone else's code. What's really nice is that sometimes you'd like to be able to see, hey, where was everywhere that this variable number1 is used? So you can kind of figure out what it's being used for. So if I just click on it and then move away, you can see it actually highlights everywhere that this particular variable is used. So it's a really nice way just to be able to skim through the code and say, okay, where's number2 used? Okay, I see now it's reading in a number from the console. Oh, and then they're adding it to number1. Oh, what are they using sum for? Well, I click this and you can see, oh, they're adding number 1 and 2 together, and then they're printing it out on the console. Another thing you can do is you can right click on these variables and you can say find all references, and that'll pop up another little window that you can double click, and that'll take you to the various points that it's used. So that's how you can use this little pop-up menu that you right click on the variables. So as we go through here, we can see they're using console.write. They're printing out the message enter the first integer. Now then it's going to wait right on that command prompt for the user because we didn't use console.write line, we used console.write. Now what we're going to do is we're going to read in some data from the console. And so we do that by using console.readLine. So this says, hey, keep reading in characters until the user presses the enter key. Where console.read, we just read in the first character. So console.readLine says type in as much as you want until you press enter, and then I'm going to read that in. Now if I highlight this, you'll notice it reads it in as a string. So it can read in anything you type in, ABC, 1, 2, 3. Now we're saying enter in an integer. So now this reads in integers just fine because it's actually going to read it in as a string. So let's say enter in 5. This is actually reads in a string value 5. It doesn't know that it's a number. It treats it just like a string like ABC. This string just happens to contain the number 5. So in C#, if you want to take a number which is stored in a string, but you want to store it in an integer data type, you have to cast it. So Visual Basic is actually very forgiving, and it would figure it out. It would just say, okay, you got a string here, I know you want to put in an integer, and it just does it for you. In C#, you have to explicitly cast everything. And so to do that, one way you can do it is to use this convert class. So this is, hey, read in this string from the console, and then because I want to store it in an integer, I have to say convert to int32. So it's saying I'm converting it to a 32-bit integer, which is what this happens to be right here, this int data type. So now when you say int, you'll notice what they've done is they've just kind of made it a shortcut to actually saying int32. So int is exactly the same as declaring it this way, int32. It's just a shortcut. That's all it is. They're the exact same thing. But everybody usually just says integer. But that's why it actually says to int32, because this is a 32-bit integer. But you could do something like a short if you really needed to use less memory, so you could use the short data type, which is 16 bits versus 32 bits. So now that's actually going to convert our number and store it in number 1. Then we're going to do the exact same thing for number 2. Now, here's where we need to be careful. Because we're doing converting this string to an integer, what would happen if I typed in ABC then pressed enter? Well, it's actually going to crash our program because we've tried to convert a string to an integer, but it was actually a string that was in this string, not an integer. So it's going to actually throw an exception and crash our program. And in just a little bit, I'm going to show you this try parse method that's actually a better way to convert data. So within this convert class, it's kind of nice because there's all kinds of conversions. So you can take data and convert it to an int32, convert it to a decimal, to date time, date formats, to singles, to strings, things like that. So the convert class is a nice class to know about whenever you need to convert class or cast data from one type to another. So then we come down here, and just like in Java and C++, if you want to do addition, we just use the plus operator and just, minus or multiplication, things like that. So in this case, we're actually just going to go ahead and add the numbers together, and then we're going to print out the data. Now this is something kind of strange syntax here. So what this is actually saying is that to print out the string to the console, sum is, and this says, hey, print out the 0 indexed variable. And so what you could actually do here is this is actually going to print in this string the sum format. And the reason for this is that you can actually say colon, and you can put in some formatting characters, which we'll talk about in a little bit. But if you had, let's say, another variable I here, you could say something like 1, for instance, and that would print out I for this. But this is just saying, hey, print the first variable, because C# is 0 based in the sum. Now the one thing, again, just like the other programs, we actually have to say console.read, or else it'll just write it and then close it right down. So let's go ahead and run this. You see, enter the first integer, let's press 3, enter the second integer, 4, press enter, and you can see the sum is 7, sure enough. And now it's waiting for me to press a key. Now if I were to run this again, and let's say I pressed A and pressed enter, and you can see your program just kind of sits for a second because it was actually trying to do this conversion and it blew up. And you can see an unhandled exception because we don't have any try-catch blocks in here, which we're going to start learning about in later lectures. And it's basically telling you, hey, it tried to format it and it couldn't do it. If you want, you can actually click View Detail, and you can open up here. You can see the input string was not in the correct format, and it actually gives you this stack trace. So it gives you the full path of how this actually occurred. And you can see it occurred in this, string to number. You can see the target site. I mean, there's all kinds of information within this error handling. But you see to yourself, you say, okay, the user should never run a program and have it crash, right? They're going to judge your program by this. So you're going to want to put some exception handling in, and you're also going to want to check this console.writeLine. You're going to want to put this into a string variable, then make sure that it is an integer that the user has inputted, then actually do the conversion. But you'd want to make sure that they've entered valid data first. So let's go ahead and stop that from executing. So now let's take a look at how you would actually debug this program. So Visual Studio has a very powerful debugger. So what I can do is I can actually just click over here anywhere on the left, and we can insert what are called debug points. Now with your debug points, you can even right click on those, And you can even add in conditions, and you can do different conditional statements. So let's say you had a for loop that went through 1,000 times and it was going through looping with this variable I. Well, I could say, hey, don't hit this debug point until when I equals 500, for instance. And that way it would just run 500 times, then it would finally hit, because maybe the 500th iteration is where an exception was thrown or you need to check some values. But let's say I've set these breakpoints now. I go ahead and click start, and you can see it ran and executed these lines of code, and then it hit this line of code and it broke into our debugger. And so now what I can do is, if you forget the commands, you can just come up to debug, and you can see if I press F5, it's just going to continue on running. I can do Shift F5 and stop debugging. Or down here, if there was a method that I could step into, I could press F11 or step over that method, so it would just go to the next line of code. I could do F10. Most of the time, you'll just do F10. So if I do F10 right here, you'll notice that it actually executed this console.readline statement. So it took me to here. So now let's put 5 and press enter. You can see it comes back into my debugger. And so what's nice is I can then highlight, for instance, number 1. And you can see right here, it actually says, hey, you've got the number 5. Well, maybe I want to actually put some different data in here. I can actually type in 10, press enter, and now this number 1 actually contains the value 10. I can also click this little pin right here, and you can see I can now move this variable around anywhere I want, and that value is going to stay right there. So I can only see exactly what it's going to be as I'm executing my program. So let's go ahead and get rid of that. Another windows we can take a look at is in my debug windows, and there's some windows right here that we're going to be interested in. The first one I want to take a look at is the watch window. So just click any one of these. So let's do watch 1. And what watch windows allow you to do is put any data you want down here, for instance, number 1, and it's going to show you the data associated with number 1. So here's the value and here's the type. So I can go ahead and I can actually type 15 in here, and it now updated this to the value of 15. So I can do anything I want while the program's executing using my watch window. Another one, if I go debug windows and I do autos, you can see all of these variables that I'm dealing with will actually pop up, the ones that I'm using. So you can see number 1 shows up here. If I do debug windows local, this is going to show all the variables within the current local scope. So as I step into methods and step out of methods, only the variables that are local to that method are going to show up here. So you can see I've got number 1, number 2, and sum are all showing up. Where number 2 and sum still have the values of 0, here's the value of 15. So as I press F10, it's going to take me back to the console now. I can enter in 7, press enter, and so you can see in my locals window here, it's updated those values. And so now I could do F10 to execute this statement. It filled up my sum, and I thought to myself, okay, you know what? That's not really what I meant to do. What I wanted was to create some sort of error condition, or I wanted to test this with some different values, but I don't want to have to rerun my program. You can come over here to this little arrow and just drag it right back up. And within debugging now, I can say, okay, you know what I actually meant? I meant to actually enter 9 here. And so now you'll notice the current value is 22. I press F10, and now it's 24. So again, I can drag this anywhere I want, and you can just keep executing that code with your debugger. Then you can press F5, and that'll just continue on executing your program, and that'll print out your total. So that's some just basic ways to debug the program. So one of the things we want to be careful with now is when we do division. Let's go ahead and get rid of our breakpoints now. So if I were to divide two numbers, we need to be really careful when both of them are integers, and we're storing that in an integer value. Now the reason for this is because you'll come up with something called integer division. Inevitably, students turn in assignments or ask me questions on why they can't get their values to end up calculating like they want, and that's because integer division. So what's going to happen here is, let's say number 1 here contains 7 and number 2 contains 4, so it's 7 divided by 4. Well, that's not going to give us a decimal number like we may want. It's actually going to do integer division. When you have an integer divided by an integer, it's going to actually do integer division, and the sum will actually be 1, because it's just going to say 4 only goes into 7 one time. Or let's say we were doing 17 divided by 5. Well, the result would actually be 3, because 5 only goes into 17 3 times. Now, if we were to use the modulus operator, which is the percent sign, if we did 17 divided by 5, it's 3 with a remainder of 2. So this would actually return the result of 2. So again, just be really careful when you're dividing by integers. And if you could you can cast these, is how you would actually get rid of integer division. So for instance, you could cast one of these to something like a double. And we're going to talk about that in one of the other little programs. So you would have to cast one of these to a double data type, or you'd have to change these to a double data type, and then it would do it for you automatically. Okay, let's go ahead and move on to the next program. We don't need to save this. So here we're going to go ahead now and learn about order of operations and if statements. And so we've got another console-based program. This is figure 3.26. As we scroll down here, we've got 2 integer values. Again, we can highlight them and we can see where they're used down below. The program is just saying, hey, enter the first number, we're reading it in, enter the second number, we're reading it in. And now we're going to kind of compare and figure out what's actually in these variables. So we're going to learn about the if statement. So again, this can look exactly like C++ and Java. The one thing to note is that in C#, when you're doing comparison, do not forget that it's a double equals. You can't use the single, like in C++, it'll allow you to do this. Why? I have no idea why you'd ever, in an if statement, actually want to assign number 2 into a number 1. But in C#, it's not even allowed. So when you're doing comparison, it forces you to do the double equal. You're going to do this 1,000 times. I do this all the time. It's just, but it's, you run it, you compile it. If I press F5 right here, you can see I get a compile error. It says, hey, cannot implicitly convert type into bool. And you say, oh, okay, I forgot. I actually meant to do a double equal sign there because I was comparing number 1 to number 2. So this if statement is going to say, if number 1 equals number 2, then do this statement here. I don't think that should be anything new to you. Within C#, if it's just a single line of code afterwards, you don't have to have these brackets. However, in my personal opinion, I think it's always a good idea to use these double brackets. So now we're just going to say if number 1 does not equal number 2, then execute this line of code. If number 1 is less than number 2, then execute that line of code. Then greater than, less than or equals, greater than or equals. So this is actually very helpful for your first assignment that actually takes some numbers and then compares them. So these are the comparison operators and using an if statement. Go ahead and close this program down. So now let's go ahead and write a little bit of our own console application, just to kind of reiterate some of these statements. So this is just a sample program, again, that I've already got out there. So what we're going to do is go ahead and say, okay, we want it to print out console.writeLine. We want to give the user some sort of message. So I say console.writeLine because I want to print a new line character. Let's say hello world. And now I can do end quote, end bracket, and you can see how it just skips over those by typing them in. So that's actually going to print out hello world. Then it's going to do a read line statement so the user could type something in. Now let's say we want to go ahead and learn about escape characters, go over that. So now we say console.writeLine. We can say hello, and let's say \t for our tab, world, and then \n for new line character, program test, just kind of writing some more information there. And then that'll print out the new line there. So the rest of this program, what this is reiterating is just, okay, we're creating some string variables that are going to hold the first number and second number. Then when it returns from the console, they're string variables. So we're just going to return them into these strings. Then we're going to convert them into actual integers, and then we're going to sum them together. So let's go ahead then and write out to the console, enter your first number. And what we're going to do now is we want to do a read line to get the first number. So what we're going to do is we're going to actually just go ahead, let's just get rid of this, and I'm going to say my S first number equals console.readLine. So now you notice what I'm doing here that's a little bit different than the other program we looked at, is I'm saying, okay, I know that this returns a string. However, I know that they could choose to enter an integer, which will crash my program. So I'm going to go ahead and just return it into a string, which can hold anything. Now I'm going to go ahead and do the same thing for this second number. So I'm going to say S second number, use my IntelliSense, equals console.readLine, and type that in. So now I'm going to read in my second number, storing both of these in strings. Now, this is the correct way to cast something from a string into an integer where it won't crash your program. If you do the convert.int32, when it doesn't have an integer in there like we did here, it's going to crash our program. And so that's why I'm saying don't use convert.int32 when you're having this string data coming in from the console, but it could contain an integer. What we want to use is this int32.tryparse. So just like you can say int32 I and declare this variable, within this int32 structure I can say int32 dot, and I can actually get this method called tryparse. And what tryparse does is it says, hey, try to parse out an integer from this string if you're able to do it. And so this is the way you would want to convert a string to an integer data type without crashing your program. So we say int32.tryparse. We pass in the string that we're trying to parse out a string from. Then what we do is if that's successful, it's actually going to pull out that number and return it in I first number. It's going to return in whatever variable. Now you'll notice I declared this thing called I first number. So this out keyword here, which you have to use, and for right now what this means is that this method is passing out a value for you, and it just happens to pass it out in this variable called I first number. So what we can do now, which is nice, is I can actually put this in an if statement, because you'll notice that if I highlight tryparse, we can see that it actually returns a bool. It says bool int32.tryparse. So I could actually either, I could say bool b is valid, something like that, and then I could say if b is valid equals true, then go ahead and do the cast, or go ahead and continue on with my program. And if this is true, then I know I first number actually contains the integer that was in the string here. Now if this was false, maybe what I would do is then I would reprint out, hey, please enter a valid integer, for instance. So just make sure that you use int32.tryparse. What you don't want to do is int32.parse, because that's going to be really similar to convert.toInt32. So in all of your applications that you write for your assignments, make sure you use int32.tryparse, and that way you can pull out this integer that was contained in this string. And then again, just showing you how you should not use it here. And now let's go ahead and add these numbers together. So I've got this isum, and we're going to set that equal to I first number. You can see it kind of fills in the capitalization for me. And then we got I second number. And so add my first number to my second number. And then we're going to actually just go ahead and pop up a message box now. And we can just go through this code and we're saying, okay, the sum of the first number and the second number, you'll notice I'm using my string values now, is I sum. And then this is my caption of my message box. I'm doing OK cancel buttons and an exclamation point. Then we come down here and I'm going to do some if statements. And so for my if statements, I'm just saying if the first number is greater than or less than here, just print out that particular message box. So let's go ahead and run it. and you can see it printed out hello world. I press enter. Now it's showing you the tab and the new line character. Press enter again, enter the first number. We do 3, then do 4 or 5, and you can see it actually prints up the sum of 3 and 5 is 8. Click OK. And it closes down my program. Now what you probably didn't realize here is I did something kind of tricky. So if I come back to my Solution Explorer, the type of project here is actually a console program. And so it should just run at the console, right? It wasn't, but I'm still using a message box. So how did I do that? Well, I had to do two things. I actually had to go to my references, right click, add a reference, and you'll notice my framework comes up here, and it's going to load all the references that I can use inside my .NET 4.5.2 framework. And one of the references I clicked on was system.windows.forms. So I just scrolled down here and said, you know what, I actually do want to use this message box because most people would never use it in a console. That doesn't even make sense. But I wanted just to show you, for example, how you add it in. So I just came in here and again and said system.windows.forms. I put a little checkbox here, clicked OK, and that added in that reference here. Then I added this using statement, so I didn't have to say system.windows.forms.messageBox. And by doing that, I now have the ability to use a message box inside of a console program. So hopefully these kind of all make sense on how you tie them together, and this should give you plenty of information to complete your first assignment.